Chapter 15, Section 2. We're going to work on reference angles today in this section. And we're going to talk about special angles as reference angles, and we're going to find exact measures. That table that we created yesterday, that 30, 45, 60 that had that sine, cosine, tangent, that table is going to be huge today. So I'm going to put it up here or down there somewhere. I'll repost it in the video, and it'll kind of play along as we're getting to that section. But if you didn't get that copied down, once I put that up, and I'll put it up when it becomes relevant, you're going to need to make sure that you have that copied down because it's going to be used a ton within this lesson and when we're talking about exact values. So make sure you have that thing. Otherwise, we're going to kind of get going here. We'll talk about reference angles and then how we go about doing these special right triangles. So a reference angle, by definition, a reference angle for angle theta is a positive acute angle made by the terminal side of an angle and the x-axis. Okay, so this piece right here, that's the reference angle. The reference angle always goes from our terminal side, which is that blue, to the x-axis, and it doesn't matter what quadrant that it's in. If it's in quadrant 1, 2, 3, or 4, it always goes to the x-axis no matter where it's drawn. So the first one shows in quadrant 1 where it goes from our terminal side down to that x-axis, and you'll notice that we can create a right triangle, and that's going to be key here in just a little bit. If it's in quadrant 2, that reference angle is right here, and it goes again from the x-axis to the terminal side. The common error, especially when you start getting like these, is to make this the reference angle, and that's not the case. It has to go to the x-axis. It's always going to be acute, and it's always going to go to the x-axis. So it's always going to be less than 90 degrees, and it's always going to go to the x-axis. If it's in the fourth quadrant, you can see where it is. That's our reference angle right there. Again, it goes from the terminal side to the x-axis. And they don't have a first quadrant one here, but if we had one that was in the first quadrant, there's my terminal side. That's my reference angle. And we always want to be able to find that reference angle, because when we find that reference angle, we're going to have all these little triangles that can be created, and then we're going to use that table to find exact values of sine, cosine, tangent, secant, cosecant, and cotangent. So that's a reference angle. So let's look at a couple of examples, but first let's talk about a common error. A common error is to find the reference angle by using the terminal side, theta, and the y-axis, and it's not the case. It's always to the x-axis, and we'll reiterate that as we kind of go along. So if we want to find the reference angle to a 218 degree angle, how are we going to go about doing this? Well, the first thing we're going to do is we're going to sketch about what a 218 degree angle would look like. So it's 218, so it's going to go counterclockwise. So we always start at the x-axis, and then we can count. There's 90, there's 180. If I kept going all the way around to the next one, I'd be to 270, so that's too far. So it's going to be in here somewhere. So that's going to be my terminal side. That's at 218 degrees. So we know that this is 218. Now my reference angle is going to be the angle that's created that goes from the terminal side to the x-axis. So we want to find the measure of that. Well, we know that this is 90 and this is 180. So if I go 218 minus 180, I can find my reference angle. So 218 minus 180 is what, 38? So my reference angle in this case is 38 degrees. And that's all they're asking for you in this, is they're asking for that reference angle. So we draw the angle, and then we just kind of look at where it's at, and then we do any subtracting or adding we have to do to get back to that x-axis. In this case, we're going to go 218 minus 180 to find it. Okay? Let's look at their explanation, and that's the same thing. Okay? So let's look at the reference angle for a 1,387, and it doesn't really matter what this is. I mean, we just have to draw it. Okay, so we go around, there's 90, 180, 270, 360, 450, 540, 630, 720, 810, 900, 990, 1080, 1170, 1260, 1350. So it's about right in there. So there's 1387. And my reference angle is going to be this angle right here. So if we go, 360 times, what do? We went 1, 2, 3, 4 revolutions. That would be 1440. So if we go 1440 minus 1387, we get a reference angle of 53 degrees. And run. Probably a faster way to do it, but that's the way I like to do it. Okay, we'll see how they do it. Okay, so they just found a coterminal angle between, which is fine. It's another way to do it, to get the same answer that we got. So here's just kind of a nice little table to how you calculate it in different quadrants. So if it's in quadrant 2, you're going to go 180 minus theta. If it's in quadrant 1, it's just theta. If you're in quadrant 3, it's theta minus 180. And if you're in quadrant 4, it's 360 minus theta. Okay, so you can press pause on the video if you need to write that down at this point. We're about 6 minutes in, so it'd be a good spot to just kind of pause for a second and get yourself resituated and make sure you're taking those notes that you need to be taking to help you for the assessment. Okay, so the next thing, so that's finding reference angles. Now you can do this for positive or negative angles. Just make sure you go the opposite direction again and remember where that terminal side is. So how are we going to use this? Well, we're going to use this to help us find exact trigonometric functions for different angles. So we're going to find a 210 degree angle. So it says find the values of the 6 trigonometric functions of 210 degrees. Okay, so step 1, and this is where we're going to start using that table. We're going to draw it. So there's 90, there's 180, there's 210 somewhere right in there. So there's my terminal side. So it's in quadrant 3, so I'm going to go 210 minus 180. So this is 30 degrees, and that's huge because what we want to end up today, and what you should end up today, is with anything that's 30, 60, you either have a 30 degree reference angle, a 45 degree reference angle, or a 60 degree reference angle. If you don't have one of those as a reference angle, you've made a mistake, because now we're going to use the table that's somewhere around me, okay, up there, because we can create a right triangle out of this. Okay, and it asked us for the 6 trigonometric functions of a 30 degree angle. So we're going to find the sine,
Austin
210,
High School, all clear. Austin
cosine
High School, all clear.
of 210,
Resume classes as
tangent of 210, cosecant of 210, secant of 210, and cotangent of 210. Now, these are going to be the same exact thing as if we did it for the 30 degree angle, because that's our reference angle. So the sine ratio is going to be the same. The only thing that's going to be different is if it's going to be positive or negative. And we'll talk about that in just a minute. So we're going to treat this as if it was equivalent to the sine of 30 degrees, that this is the cosine of 30 degrees, that this is equal to the tangent of 30 degrees, that this is equal to the cosecant, the cosecant of 30 degrees, the secant of 30 degrees, and the cotangent of 30 degrees. Now, that's not entirely true, because we have different things that we need to do as far as where are they positive and where are they negative pieces of this, right? So we've got this 30 degree angle. So if we look at the 30 degrees, the 30 degree triangle that we talked about in yesterday's lesson is, we said the side opposite the 30 degrees, we labeled that as 1. We labeled the hypotenuse as 2, and the side opposite the 60 was the square root of 3. Now here's where kind of the positive and negatives come into effect. It's because this has to be negative and this has to be negative, because we're going to the left and we're going down. So we're going to have to mess with some negatives in here, but we can look at our table now and say, okay, the sine of 30 is 1/2. But if we look at this, sine is opposite, which would be -1 over -2. So this, in fact, is going to have an answer of -1/2. We'll use the ratio from the table that we created, but then we have to determine if it's positive or negative. So cosecant is adjacent over hypotenuse. So if we look at our thing, our table says it's the square root of 3 over 2. That's our cosecant, or that's our cosine, but also notice that it's going to be negative at that point. Okay. Tangent of 30 from our table is the square root of 3 over 3. And tangent is opposite over adjacent. So if we look at our opposite side, that's negative, and so is our adjacent side. So tangent, in fact, is going to be positive. So it's just going to be the same, square root of 3 over 3. The cosecant of 30 degrees is 2. The cosecant is going to have the same as sine as the sine, so that's going to be -2. The sine of 30, if we look at our thing, so the secant of 30 is 2 radical 3 over 3. And you'll notice I'm looking to my right, which I've got the table sitting there, just like you're going to have the table. You need to have the table sitting there. Secant's going to have the same sign as the cosine, so that's going to be negative. And the cotangent, if I look at my cotangent, it's the square root of 3. And it's going to have the same sign as my tangent. So there are my 6 trigonometric ratios for these. Okay. And again, I'm looking at the table to do these, and these things are kind of referenced. So maybe the best thing that we could do now, and we're going to go through the answers to this to make sure we got them right, but which I know we did. And they did it. I mean, they didn't look at the tables, but whatever. I mean, it's the same answers that we got if you want to look through there. They did it differently than we did because we're just looking at the tables. We're not going to use these different ratios that they use. We're looking at just that table that we created yesterday, and you need to use that table. So whatever that says. Okay, so we're going to do another one, but what I want to do first is I want to kind of let's go through a positive and negative kind of table here. And this is something that, again, needs to be in your notes. So in this one, all 6 are positive. Okay. In the first quadrant, all 6 of them are going to be positive. Okay. In this one, the sine is going to be positive. Cosine is going to be negative. Tangent is going to be negative. And then the reciprocals are just the same. Okay, so that means the cosecant is positive, the secant is negative, and the cotangent is negative. In quadrant down here, the sine is negative, the cosine is negative, the tangent is positive. So that means the cosecant is negative, the secant is negative, and the cotangent is positive. And in the fourth quadrant over here, the sine is going to be negative, the cosine is going to be positive, the tangent is going to be negative, the cosecant is going to be negative, the secant is going to be positive, and the cotangent is going to be negative. So again, pause the video, get that table down, because that table is going to help us do what we need to do here in just a second. So let's look at the exact values of the cosine, and it just wants the cosine of -240. So step 1, we're going to draw it. So we're going negative. So there's -90. There's -180. If I go all the way, it's 270. So I'm not going to go all the way. We're just going to go to there. Okay, so this is -240. Oops, yeah. So this is -180. This is -240. So that's going to give me a 60 degree reference angle. So it's asking us for the cosine of negative 240. That's going to be the exact same thing as the cosine of 60 in that quadrant. And we need to know the quadrant because we need to know if it's positive or negative. So if we look at our table over here, the cosine is negative. If we look at our table, it says the cosine of 60 is 1/2. So we know the answer to this is going to equal negative 1/2. And you're done. You've got to have this down, and you've got to have this table near you. I'm looking at them. Okay, I don't have that table memorized. I've got this one kind of memorized, but I don't have that table memorized. I know another way to do it if I don't have it, but whatever. Okay, we need to have these different types of things in our kind of our wheelhouse. Okay, what's the exact value of the tangent of 675? Okay, so first we have to figure out where it's at. So we can go around the table and whatever. So there's 360, 450. What's that? What did I say? 360, 450, 540, 630. So it's going to come over in here. We said everything has to be a 45, 45, 90. Well, it ends in a 5, so this is going to be 45. Okay, so we're in quadrant 4. So the tangent in quadrant 4, is that positive or negative? Okay, it's negative, so we know our answer is going to be negative. And we look at our table for tangent of 45. Tangent of 45 is 1, so our solution to this is negative 1. So again, you have to draw it because you have to figure out if it's positive or negative by using the table, by using the drawing. And then we use our table for that reference angle 45, and we give it the answer that that has. And tangent is -1. It's almost like we know what we're doing. We're not going to do these because we don't have to. Okay, so we're going to evaluate in this case, we're going to evaluate the cosine of the exact value of the cosine of 780. Okay, so we're going to draw it. There's 360. There's 720, so it's going to go right here somewhere. So that's 780, and we went to 720, so we know our reference angle is 60 degrees. We have to find the cosine. So we look positive or negative. Cosine in the first quadrant is positive. It's going to have the same as the 60. Cosine of 60 is 1/2. So our answer for this is 1/2. And we're done. They probably did it a little bit different, but again, we got the same answer. Okay. Negative 405. We know that's negative 360. So it's going to end up in here somewhere. It ends in a 5, so that means we're going to go 45. Tangent here is negative. So tangent is negative. It's going to have the same thing as 45, which we've already said was 1. So our answer for this is -1. Important that you have those two things down and you use those two things. Let's do the sine. Let's do the sine, cosine, tangent of 390 degrees. And let's just do the secant, cosecant. Well, let's make it the cosecant, the secant, and the cotangent as well for 390. Okay, so step 1, draw it. There's 360, a little bit more. Okay, so my reference angle is going to be 30 degrees. So 390 is going to have the same ratio as a 30-degree angle. We just have to talk about positive and negatives. So it's in the first quadrant, so everything's positive. So everything's going to be just like it is in a 30 degrees. So we go over to our table. The sine of 390 is going to be 1/2. The cosine, the square root of 3 over 2. Tangent, square root of 3 over 3. Cosecant is 2. Secant is 2 radical 3 over 3. And cotangent, again, I'm just looking at my table, square root of 3, done. Okay. So those are the things that you're going to be expected to be able to do today. Find that reference angle, find that exact value using your table and the chart for positivity for our different trig ratios. That completes section 5.2, and we're looking at a quiz here probably on Thursday or Friday of this week. Talk to you later.